So how would we go about doing the integral of 1 over 1 plus e to the x? We could try substituting u equals e to the x right away, which means du is equal to e to the x dx, and if we divide e to the x on both sides, we get dx equals 1 over e to the x du, and since u equals e to the x, this is just equal to 1 over u du, so we have an expression for dx entirely in terms of u, which is dx equals 1 over u du. If we substitute all of this back into the expression, we end up with this integral in terms of u, which means we have to do partial fractions. We could definitely do that and it would work, but I don't really want to do that. I actually have a better idea. Why don't we just say that instead of 1 over 1 plus e to the x, we rewrite the numerator of the integrand as 1 plus e to the x minus e to the x all over 1 plus e to the x. And this expression is still the same because all I did was added e to the x, then subtracted e to the x in the numerator. This allows us to split the fraction and rewrite the integrand as 1 plus e to the x over 1 plus e to the x minus e to the x over 1 plus e to the x. You might ask what the point of adding e to the x then subtracting e to the x in the numerator was. And it's so that we have the 1 plus e to the x term in the numerator, which would cancel out nicely with the 1 plus e to the x in the denominator. So the 1 plus e to the x over 1 plus e to the x simplifies to 1, and the minus e to the x over 1 plus e to the x stays the same, which means the integrand is just 1 minus e to the x over 1 plus e to the x. We still have a fraction with e to the x terms we have to contend with, but this one is so much easier because you may notice that the numerator is the derivative of the denominator. The expression in the bottom part of the fraction is 1 plus e to the x, and if you differentiate that, the derivative of e to the x is still e to the x, and the constant term of 1 disappears. So the derivative of 1 plus e to the x is e to the x, which is what we conveniently have in the numerator. Great, so this means the fraction is in the form f prime of x over f of x, where the numerator is the derivative of the denominator, and whenever that happens, we can use the formula. The integral of f prime of x over f of x dx is equal to ln of the absolute value of f of x plus c. So if we integrate this expression term by term, the integral of 1 is x, and the integral of e to the x over 1 plus e to the x is ln of the absolute value of 1 plus e to the x, since in this case, the f of x is just 1 plus e to the x, and the numerator is the f prime of x, since the derivative of 1 plus e to the x is simply e to the x. And of course, we have to add the constant of integration c at the end. So the integral of 1 over 1 plus e to the x is x minus ln of the absolute value of 1 plus e to the x plus c, since there was a minus sign before the fraction in the integrand. And we didn't even need to use partial fractions. Actually, we can rewrite this as x minus ln of 1 plus e to the x plus c without the absolute value in the logarithm, since 1 plus e to the x is always positive, so the absolute value isn't needed.